Welcome to this video on finding the sample size needed to construct a confidence interval for quantitative data. Let's begin. When finding n to construct a confidence interval, you should be able to determine the appropriate equation to use, evaluate the appropriate equation for quantitative data, and round appropriately. Let's begin. You've probably heard the expression time is money. This is especially true when it comes to collecting data. Suppose you are a contractor for a company. They ask you to create a confidence interval to estimate the number of people living below the poverty level in a given county. However, they are only willing to reimburse you for 100 hours of work. Therefore, you cannot waste time collecting more data than you need. Instead, you must determine the minimum number of data points that will achieve the margin of error and confidence level the company has determined is acceptable. Suppose that you know the confidence level you desire, which is 95%. You know the maximum margin of error your application allows. In this case, let's say it is 15 people, and you are given the population standard deviation. Let's say it is 134 people. How can you find the sample size you need? Well, the first thing you have to ask yourself is, what data type are you being supplied with? Are you working with quantitative data or categorical or qualitative data? Which of these two data types do you have? Either way, you have to start with the equations used to find the margin of error in a confidence interval. The equation for the margin of error for quantitative data is as shown, and here's the equation for categorical or qualitative data. Then you can use algebra to rearrange both equations and solve for n in both cases. So what do we have in our question? Do we have quantitative data or categorical data? Well, let's look. The key here is it asks us to build a confidence interval to estimate the number of people living below the poverty level. So is the number of people, is that a count, a measure, or a label? So the number of people, we would count the number of people. So since it is a count, we would be dealing with quantitative data. Therefore, we have to use this formula right here. So now that we have the information we need, let's plug these values into the equation to find n. So here's our equation. We've been given the confidence level, which was 95%. We can use this to find the z of alpha over 2, which in our case is 1.96. Then we have been given the margin of error, which is 15 people, and we can plug that directly into our equation. Lastly, we have been given the population standard deviation sigma, which is 134 people. Now that we have all those values, we can plug them in and use a calculator to evaluate them. So the answer is 306.5767 ... So then the question becomes, what should we round this value to? Should we keep it at 306 or round it to 307? Well, before I answer the question, I want to ask you a question. Suppose you're at McDonald's and your meal is $7.30 and you give the cashier $7. Will you get your food? No. Suppose your meal costs $7.06 and you only give the cashier $7. Will they give you your food? Well, they might. They might be nice and say, oh, what's 6 cents between friends, and then hand you your Happy Meal. But they might not, right? Because it really isn't enough. Okay, so our normal rounding rules, which is 4 and below, leave it alone, 5 and above, give it a shove, as you can see here, don't really apply to, for example, McDonald's and paying for your food, right? They also don't apply to finding n, finding our sample size. So in other words, if we have anything at all besides 0 after our decimal point, we must round up. Because like the money example, right, we don't have enough. If n has to be 10.4, then guess what? We can't survey 10.4 people. It has to be a whole number, right? We can either survey 10 people or we can survey 11 people. We can take 10 widgets off the assembly line or we can take 11 widgets. We can't take half of a widget off the assembly line. So if we need more than 10, then guess what? We need 11. So again, normal rounding rules do not apply. So again, the sample size has to be an integer. It has to be a whole number in this case, and we can't follow normal rounding rules. So in this case, we are going to round up to 307. And you might notice, well, in this case, it's not a huge deal because rounding rules would suggest, since it's 0.57, 5 and above, give it a shove, normal rounding rules would suggest to round to 307 anyways. And you would be right if you argue that. Okay, but the point is, even if it was 306.00001, I would still have to round up to 307 people. So, in conclusion, we have learned which formula to use, and that's based on what data type we are being supplied with, whether it's quantitative data or categorical data. And here is the formula that we practice using for quantitative data. We also learned that our sample size, when we're all said and done, has to be rounded to an integer, and we can't follow normal rounding rules. In fact, we always have to round up. So now that you've watched this video, you should be able to do the following when finding n to construct a confidence interval. Determine the appropriate equation to use, evaluate the appropriate equation for quantitative data, and lastly, round appropriately.